The geometric series is the sum of a geometric sequence. So for example, a geometric sequence might be something like this: 2, 4, 8, 16, right? This is a geometric sequence. Why is this a geometric sequence? Yes, it's being multiplied by 2 every time. So this is a geometric sequence. A geometric series is when you add these terms together. Okay? So we're going to, instead of having to add all these numbers together, I'm going to give you a quick formula. So the quick formula to figure out what the geometric series is A of 1 minus r to the power of n over 1 minus r, where n represents the number of terms. Yes. A1 is the first term. What do you guys think R stands for? The ratio. So in this case, our ratio was 2. We multiplied by 2 every time. So we have to figure out what the ratio is. Oh, and guys, the full correct word is the common ratio. Sorry, common ratio. All right, so let's start off with an example. Let's do this example. Now, guys, we need to figure out what the common ratio is. Remember, we need to know what R is so that we can plug it in to the formula that I just gave you. We have to find what the ratio is. So we're given these numbers. Let's figure out the ratio. What is negative 36 divided by 72? Negative 1/2. Let's do the next two consecutive numbers. 18 divided by negative 36 is negative 1/2. Let's do the next two consecutive. Negative 9 over 18 is what? Okay, so it seems like my common ratio is negative 1/2. I'm going to write down the formula real quick so that we can be reminded of it. The sum is the very first term, 1 minus r in over 1 minus r. So guys, I already know what the common ratio is. I can erase these r's and replace it with negative 1/2. Negative 1/2. Okay, do we know A of 1? 72. This is the very first term. So I can replace A1 with 72. And guys, what term am I going up to? 8, right here. We want the sum of the first 8 terms. So the number of terms I want are 8. So I'm going to replace these n's with an 8. All right, guys, please type that into your calculator. Let me know what you get. Okay, so you should have gotten 765 over 16, or if you put it as a decimal, 47.813. 47,813,000. Okay, let's do another example. All right, guys. Looking at this equation, it's too loud in here. Looking at this equation, let me remind you of the formula for a geometric sequence. Geometric sequence formula. Do you guys remember it? Perfect. So this was a geometric sequence formula. So guys, looking at this and looking at this, can you tell what the ratio is? 2. 2. Can you tell what the first term is? -5. -5? Okay, well, let's check and make sure. I'm going to plug plug in a 1 because that's my first term. What's 1 minus 1?
0.
What's 2 to the 0?
1.
And what's 1 times -5?
-5.
So, yep, the first term is -5. So, guys, let me remind you of the formula that we learned today. Geometric series is A1 times 1 minus r to the power of n over 1 minus r. So let's go ahead and plug in our numbers. The very first term is -5. The ratio is 2. And the n value. Do you guys remember how we find the n value? Yep, the number of terms. So we have numbers 1 through 18. That is 18 terms. So I'm going to erase this, put an 18. All right. Let me know what that's equal to. Say it again. -1 million.
Yes.
310,715. There we go. Let me remind you of our formula. The sum is A of 1 times 1 minus r to the power of n all over 1 minus r. Looking at our equation here, what is our ratio? -5, that's this number, the number that has the exponent, that's your ratio. So I'm going to go ahead and substitute r with -5. Okay, now let's figure out what our very first term of this series is. What do you think it is? Let's see. This is the very first term. We're starting with 5 this time. In previous examples, we started with the 1. Now we're starting with the 5. So let's plug in a 5 here. What do we get? 1 over 20 times -5. 5 minus 1 is 4. Can you guys type that in? Let me know what that is. I'm sorry, say that again. Thank you, 125 over 4. So guys, that's our very first term. That's going to go right over here for the first term of our series. 125 over 4. This number always represents what you're starting with, your first term. In this case, it was 5 instead of 1. Okay, now let's talk about the number of terms. What do you think the number of terms is going to be? 8? Okay, let's see. I'm going to do it just the long way. I'm going to be plugging in numbers 5 through 12. We already plugged in 5 and we got this. Next, you would plug in 6, 7, 8, 9, 10, 11, and then finally, you would plug in a 12. That's 1, 2, 3, 4, 5, 6, 7, 8 terms. Okay? So that means my n value is 8. Okay, a quick way to figure this out, guys, what we learned yesterday is do 12 minus 5. So you do this top number minus the bottom number, and you get, what is this? 7? And then you add 1 to it to get 8. You always got to add 1. That's a quick trick. All right, guys, plug this in and let me know what you get. -2,000. 34,500. Okay, let's try this problem. So before we start, let's look at the formula for a geometric sequence. For a geometric sequence, the formula is A1 times R to the power of n minus 1. So guys, we don't know what term this is. I don't know the end value, but I know what the whole total is equal to. The whole total is equal to this number. I just don't know which term it is in the sequence, okay? So let's go ahead and fill in what we know. I know that we have 384 equals, the very first term is -4 times, we don't know n minus 1, but we do know the rate. How is this increasing each time? Yep, it's multiplying by 2 every time. So that's my ratio. Okay, so let's go ahead and solve for n. We're going to divide by -4. When you divide by -4, can y'all tell me what we're going to get? What do you guys get when you divide this? 4096. This should be positive since these are both negative. Okay, so now guys, I'm going to go ahead and take the log of both sides. When I take the log of both sides, this becomes log of 4096 equals, remember, we have to do the power rule. This exponent can come to the front. N minus 1 times log 2. What do I do now? Yes, divide by log 2. Divide this side by log 2. If you put this into your calculator, you will get 12 equals n minus 1. Finally, I'll just add 1 to both sides, and I get n equals 13. So guys, what this means, that means this was the first term, this was the second term, this was the third term, and then it went all the way to the 13th term. We figured out what the 13th term was, okay? Now, we are doing a geometric series where we're going to add up all these numbers in the sequence. From 1 through 13, we're going to add up all those numbers. This is the formula. Okay, so guys, how many numbers are we adding together? 13, we just found that out. So I'm going to plug in a 13 for the n value. What is our ratio? 2. And what was our very first term? Right here, -4. Now, type this into your calculator and let me know what the value would be if you added up every single term in this sequence up to the 13th term. -32,764. Perfect. So if you add up all those numbers, you'll get that.